Hello everybody, this is Mustafa from the Code Show, and in this video we are going to solve a very popular backtracking problem, which is a queen problem. So it's a very popular one, and it exists in two questions in Leetcode, question number 51 and question number 52. So yeah, let's jump into it. So let's start with 52 because it's much simpler than 51. So yeah, let's start with the problem statement. Here, given you have n chess queens, and you need to place them on n by n chessboard in a way that any of these queens shouldn't attack each other or couldn't attack each other. Okay. For example, if you have like 4 and you have 4 queens and 4 by 4 chessboard, you need to find the solution, the multiple solution actually, of where you will place those queens. Okay, so here we have 2 solutions, so our program will output there is 2 solutions, and there is another constraint that n is less or equal 9 and larger or equal 1. Okay, we have a very tight constraint. Okay, it's between 1 and 9. Okay, so how we should solve this problem? Yeah, it's a pretty tricky one. So actually, first thing, we need to represent these queens in whether a 2-dimensional array or 1-dimensional array, just to make sure that we are representing the queens in a way that we can check these queens with. Okay, so for example, if you have in my solution, I will have those queens in 1-dimensional array, and the index of this array actually will represent the row, and the value of this index will represent the column. So I'm going to represent these queens in the array. So the array should be something like this. This is just pure example. Equal. Okay, so my first row here will be my first item, and the value of the row of the column will be the value of the first row. Okay, so this is the first row, and the value of it will be 2. Okay, so this is a 0-based array, and the second one here will be 0, and the third one actually will be 3, and the fourth and last one will be n1. Okay, so this is how the final solution should look like. Okay, so let's start. Actually, we will also, or one important thing, our solution, in our solution, actually we will need to check before we place any queen, we need to check for the column and the row and the diagonals. Okay, we have 2 diagonals here. This is the way the queen actually can attack any piece in chess. So we were going to check the column and the rows and the diagonals. Okay, in our solution we are going to discard the rows because actually our recursive function will add and will always increment the rows by default, so we will need only to check the columns and the diagonals. Okay, so here is one example here how we can check the diagonals. So to check the diagonals, if any queen that if any piece of chess in the same diagonal, or any other queen in the same diagonal, they should look like this is the slope of a line. Okay, so how we get the slope of a line? We actually subtract the first from the first and the last from the last here. So 3 minus 2 is 1, and 1 minus 0 is 1, so it's equal, so they are in the same diagonal. You can do it with any point you want, and it will be working fine. Let's take another example. Here, for example, 0 from 0, 1 from 0 is 1, and 0 from 1 is 1. So absolute difference between them is 1. So they are actually located in the same diagonal. So this is how we check the diagonal. And checking the columns actually is pretty simple, because we using a one-dimensional array. So we will check it directly from this array. Okay, let's start. Actually, the result will be and the constant result will be 0, and we need to define our queens array, okay, which will represent our queens and the solution. So we will create an array of n, and we'll fill this array with -1 value. We don't have any column or any value with -1 in the array, so just to make sure this value is will not be used as a solution. Okay, so we will use it as a -1. Let's start with our recursive function. Let's call it solve. So function solve will take the row, the number of the row. Okay, first thing we'll write our base case. If the row actually equal n, we need to increment the result, because we already reached our base case. And let's do our recursive cases. So we need to loop over the columns. So let's define a column equal 0, and column is less than the number n, and let's increment the columns. Okay, and we need to check if this position of row and the column is valid, so we can place our queen here. Okay, so how we do this? We will write another function that we will check the column and row for this specific place. Okay, so let's call it is valid. We will write this function later. We'll take row and columns, and if it's not valid, we will need to skip, continue. Okay, and if this position valid, we will mark this position as it is taken. How we do this? We will add this to the one-dimensional array here. This one, as we mentioned, the row actually will represent the index will represent the row, and the value will represent the column. Okay, and after this we will do our recursive call by incrementing the row by 1, and we will undo what we already did before here. Okay, so yeah, that's it for the recursive function. We need just to call it here, and it for sure it will start from 0, and we need to return the result. Okay, so what is missing still here is valid function. Okay, so this function, as we mentioned, we check the columns and the diagonals. Okay, function is valid, and it will take row and columns as arguments. Okay, and for we will loop over the array we already have. the queens array I mean, and let I equal 0. I is just a counter, okay, so it's 0, and I is less than the row, the current row, okay, and this the current row, and we need to increment the counter, okay. So here is if statement to check the diagonals, okay. Need to use mass, not absolute, just to check the absolute difference between the column and the rows. So here, if the column, which is represented by this counter, minus the current row, equal the absolute value of queens of the current also column minus the column. This means this 2 points actually in the same line slope, okay, which means this is diagonal points, okay. So this is the check for the diagonals. We also need to write another one for checking the columns, okay. So if the current column already exists, we need to return false, okay. Otherwise we will return and yes, that's basically it. This is the valid function, and this is the recursive function, and we just return as a result, okay. Let's run this code one more time. It's called queens, not queen, okay. So queens. Here is a type. Actually, we defined the result as a constant, and it should be closed, not a constant, because we increment it. So this is the issue, okay. It's working fine. Let's discuss it one more time actually here. So we are making sure that we explain it in the right way, okay. So we will use a one-dimensional array. This array, we will use its index as an indicator of each row, and we will use the value of each index as an indicator of each column, okay. So here, as I mentioned before, here is the row, the first row. We will so the first value of the array should contain value. The first index of the array should contain the value of 2, okay, because this is the value of the column, okay, and so on. So we are representing the row as the index and the column as the value of this index. One more thing needs more explanation is how we check for the diagonals. So how to check the diagonals? We will just do a simple math. The simple math is actually to check if these 2 points in the same slope or the same slope of the straight line. So how we check this? We actually minus the first value from the second. Here is the example. We minus the first value from the first value and the second value from the second value if the absolute difference between the first one and the second one is equal. So this means the 2 points actually in the same slope. So that means they are in the same diagonal, okay. So that's how we check the diagonals. And for checking the column, if it exists before, and if any of this true, we will return false because it's not valid to add any other queen in this place. otherwise we will return true. And we will do our simple recursive or our simple backtracking blueprint. Here we do and we recurse, and here we undo what we already did before. Okay, and then we return the result. Let's submit it. So let's discuss the other one. Here it is the same problem actually, but one extra thing actually is to represent the solutions in this way. Okay, so we will represent an empty square with dot and a queen with capital Q. So how we do this? It's a very simple thing. We will reuse this solution here. Sorry. Yeah, we will reuse it here. We will just do a simple loop to print out or to return out these values. Okay. Yeah, it's a very basic loop. Let's make a function, another function called makeBoard. It doesn't take any arguments, and it should have an array const board. This board is empty for now, and we will need to do a simple two loops, okay, inside each other, for loops for let r, which represents the rows, equal 0, and row is the n, and we will increment the rows, and we have the row as an empty string. Okay, and another loop for the columns, let columns equal 0, and the columns is also less than the number of queens, and we will need this 0. We need to increment the columns 0, and that's it. We will need to check if in the queens array there is a value of r of the column equal the current column. Okay, we will add to the row, concatenate to the row a queen. Okay, otherwise we will add to the row we will add an empty dot. We will add a dot. Okay, and after each loop, after each column, we will push it to the board. Push. Okay, we will push the row to the board. Okay, and at the end, we will need to return the board. Okay, that's it. And yes, we need also to fix our base case here. And instead of just incrementing the result, okay, we will have an array instead of a number. Okay, and we need to make the board here. Board, make board. Okay, and we will push it to the result array. Okay, and yeah, I think that's it. Let's run the code. Yeah, it's working fine. Let's submit it. Yeah, working fine. Okay, and that's it. This is how to solve problem number 51 and problem number 52, hard problems from Leetcode. That's it. See you later, guys. Bye.